Two knights are going to joust. They're on horseback 100 meters away from each other. Sir Albert is up here on the left, and Sir Benedict is over here on the right. Sir Albert is moving 12 meters per second to the right. Sir Benedict is moving 14 meters per second to the left. And if you take a look, I have a little black arrow right beneath us here, or to the right, of Sir Benedict's velocity. And what we have there is right being positive and left being negative. So when we plug in our numbers into our variables, Sir Albert is moving 12 meters per second to the right, so his velocity is positive. Whereas Benedict is 14 meters per second, but it's to the left, so his is a negative velocity. Very common mistake, people want to plug in 100 meters into one of the D's for either Albert or Benedict, but that doesn't make any sense because neither one is going to travel 100 meters. They're going to stop somewhere in the middle when they run into each other. So we can't plug that in. What I will do is write down my constant velocity equation for Albert, which is d equals v times t. And I have my constant velocity equation for Benedict, which is d equals v times t. Now, Benedict is actually going to get one thing added to his equation, and here's why. The d, when we use this equation, actually technically stands for displacement. A lot of people assume it means distance, but it's actually displacement. They're very similar things, but here's the difference. Displacement is your distance away from a particular origin point. It's how far away you are from some reference point. Now, in this problem, what I'm going to say is that Sir Albert is going to be our reference point. I'm going to say that he is at position 0 at the start of the problem. What that means is Benedict is 100 meters away from position 0. So at time 0, he needs to have a d value of 100. His position is at 100. It's 100 meters away. So how do I make this equation of d equals v times t equal 100 at time 0? What I do is I just add in the fact that Sir Benedict is an extra 100 meters away. And now Benedict's equation is correct. What we have are two d's. They're both displacements or positions. We want to know when those positions are going to be the same, because when they're the same, that's when they run into each other. And we also have times. And the times are going to be the same because they both start at the same time, and it takes them an equal amount of time to get to one another. So what that means is we have two equations, both with two variables, d and t, and we need to solve them. This is a simultaneous equation. The easiest way to set up our simultaneous equation, since both are already equal to d, is to make the two equations equal to each other. So on the left, I have Sir Albert's velocity in time. It's going to equal Sir Benedict's velocity in time plus 100 meters. Now I have red to denote Sir Albert and green to denote Sir Benedict. If you don't have colored pencils, you might want to put a little A or a B next to each one so that you can keep track of which variables belong where. To solve for time, easiest way to do that is to get both t's to the same side of the equation. So my left side of the equation is going to remain unchanged. My right side, I'm going to subtract the v times t of Sir Benedict, and the 100 is going to remain on the right side of the equation. Now what I've got to do is I've got to factor out this t. I bring t to the outside, and what I'm left with is Albert's velocity minus Benedict's velocity. And I leave my 100 meters alone. No reason to mess with that. From here, what I'm going to do is I'm going to divide Albert's velocity minus Benedict's velocity, what's in the parentheses there. And that's going to give me on the left side of my equation time all by itself, which is what I want. On the right side, I'm going to get 100 meters alone in the numerator. And in the denominator, I've got Albert's velocity minus Benedict's velocity. Now I can plug in some numbers. My numerator remains unchanged at 100 meters. And in the bottom, Albert has a speed of 12, or a velocity of 12 meters per second. And Benedict has a velocity of negative 14 meters per second. When I plug all of that into my calculator, what I end up with is a time that's equal to 3.85 seconds. And that's how long they will both be traveling before they actually run into each other. Now what I can do is I can take that time and I can plug it into the t in one of my initial equations and plug in and get the d, which is what I really want, where they're going to be. I'll use Sir Albert's equation just because it's a little bit easier without the 100 added in, and it's already set up for what I want. D equals velocity, and his velocity was 12 meters per second, multiplied by the time, which we just solved for, 3.85 seconds. Almost ran out of room there, but we just had enough room to fit it in. And when I plug that in, what I end up with is how far away will they be when they collide? They will be 46.2 meters from Sir Albert. And that's where they'll be.